Hey everyone, this is the next video on curve sketching. Gonna leave this one to you. Try to sketch the curve. Give you a hint. Domain is all real numbers. And there are no vertical or horizontal asymptotes, although I'd like you to verify at least for the horizontal asymptote. See if you can do that. Okay? So try that one on your own. Let's go to example 3. Sketch this curve and another rational function. And again, I don't mention it, but also find intercepts. Okay? So first off, again, we're going to let f of x equal y. Okay, that's that guy. So f has domain. Well, I hope you can just sort of look at this, eyeball this, right? Right? Everything except 0. Next up, vertical asymptotes. Well, again, that should be obvious. Right? Vertical asymptotes, x equals 0, right? That's where you're dividing by 0. Now, let's just be a little careful with these limits as x approaches 0. Let's say from the left. Okay, so 0. So the bottom, just note, is always going to be positive. And the top is always going to be negative. So I think we're actually getting this. So I guess actually we could have just taken the double-sided limit and gotten away with it this time. But that's what we're going to get. Okay? Again, we didn't need this part to see that it was a vertical asymptote, but it is important to know how the function behaves in the asymptote. For the horizontal asymptotes, well, we take the limit as x approaches infinity and negative infinity. Let's do infinity first. And maybe we can just see that, again, multiply by 1 over x, the top and the bottom. So you get 1 minus 1 over x. And we see that that's going to equal 0. Again, you can just save some time by noting that's the same as limit as x approaches negative infinity of f of x, right? Okay. Just maybe drop this guy down a little bit, make it look a little neater. Plenty of space. Okay. So f has horizontal asymptote, y equals 0. Okay. Last but not least, doing fine on space here, okay? So we want to find the y and x intercepts. So I'll say, okay, f of 0 equals, f of 0 does not exist. So f has no y-intercept. Well, unusual, but it happens. Okay. Now, we could also note that f of x equals 0. Was that x minus 1? No, yeah, x minus 1. Over x squared equals 0 at x equals 1. That's pretty straightforward. Might be a little tougher if you had a polynomial or something, had to factor it, but this is pretty straightforward, right? So f has x-intercept x equals 1. All right, yeah, we got some more space on the first page, but let's go to the second page. Right, so we're going to find the derivative, right? We're going to let the derivative equal 0. Let f prime of x, was that x minus 1 over x squared? Okay, so that's going to be low d high minus high d low all over low squared. We're going to let that equal 0. And again, note that f prime does not exist at x equals 0, right? We're dividing by 0 there, okay? Now, we can actually clean this up a little bit, right? Knock this off, right? Remember, if you're going to cancel out something on the bottom, you have to cancel it out from each term on the top, which we can do, okay? So again, f prime of x, just want to clean this up a little bit. This is going to equal x minus 2x plus 2. So I think that's 2 minus x over x cubed equals 0. And I think that's pretty clear that it equals 0 at x equals 2. All right. So f has critical point 2 comma f of 2, which is 1/4. Right? That was f of 2. Right? Just to be crystal clear how I got that. 2 comma f of 2, which is 2 comma 1/4. All right, let's hold off on the maxes and mins, intervals of increase and decrease until a little bit later, right? Until after we do the second derivative stuff, right? That way we do the chart all in one go. So let's do it, right? So for part 5, we are all done here. Let f double prime. Okay, so remember, we're going to take the derivative of that guy, right? That's just a bit easier, right? We're going to let it equal 0, right? So low d high minus high d low all over low squared. We're going to let that equal 0. Again, can simplify a little bit. So we're going to have that f double prime really equals, what's that going to be? Negative x plus, is that plus 3x? So is it, they're going to be 2x? Yeah, so I guess we're going to get 2x minus 6 all over x to the 4th equals 0. And again, I think that's pretty clear that that happens at x equals 3. Though again, it is worth noting that f double prime does not exist at x equals 0. Okay, so now let's do our chart, right? F prime up here, f double prime down there. Critical number was 2 for f double prime. Possible inflection number 3. And we do also have to note that we have 0, right? That's a critical number for both f, and also a possible, number of concern for f double prime, right? All right, so we plug in points, see what happens. We plug -1 into f prime right up here. So I think we're getting a positive top and a negative bottom, which strikes me as negative. Well, negative, okay? If we plug in 1 to f prime, we get that. If we plug in a bigger number than 2, we're getting a negative top and a positive bottom. So we get that. Now, if we go to f double prime, plug in a number less than 0, top is certainly negative, bottom is certainly positive, so we have a negative. All right. Plug in a number between 0 and 3. Well, let's see. The top is still negative, and the bottom is still positive. A little bit interesting right there, right? We actually still have a negative right here. So it didn't change signs, the second derivative. All right. And then let's take a look, of course, after 3, right? Then we get some positive stuff going on there, right? Okay. So let's take a look at what happens here. First, let's jot down some information. So it might look like f has a minimum at 0, but you have to keep in mind that's actually an asymptote. So no, it doesn't. So f has no local minimum, but it does have a local maximum. So believe it or not, 1/4 is actually your maximum. Somehow that's like the highest value that you get, at least around there. All right, anyway, Yeah, okay, that makes sense. Sorry. Okay, so we get that. F is decreasing on negative infinity to 0, union 2 to infinity, and increasing on 2 to 2. Also, F is concave down on negative infinity to 0, union 0 to 3, and concave up on 3 to infinity. Also note that F has inflection points 3, F of 3, which is 3, comma, what's that, x minus 1 over x squared? 2/9. It's a 9, right? All right, so that's what we have. I think that's all the data we need, all the stuff we need to write down. How about that graph? So the values in question, right, are, x equals 2, x equals 3. Intercept, what do we have for the intercept? No y-intercept, but we did have an x-intercept at 1. So maybe we can mark that point down. We also know that f of 2 equals 1/4. And that f of 3 equals 2/9, which is a bit less than 1/4. Actually, let's try to maybe scale this a little bit better. Maybe this is 1/4. And we'll say that's what 2/9. Okay? So we have like this and then this. Okay? We also have our vertical asymptote. And we also have our horizontal asymptote. Okay. So let's see what we were doing, right? I think we were decreasing concave down right before the asymptote. Again, that makes sense because when I went up there and checked for a sec, right, the limit was negative infinity. So good, that makes sense. Also keep in mind that we want to be close to our horizontal asymptote. Then keep in mind we're coming up from here, and then up we hit our x-intercept. Well, actually, hold on a sec. Let me just do that slower. Hit our x-intercept. Hit our local max, right? And again, note that it's concave down, increasing but concave down. Then from 2 to 3, we are decreasing concave down, so it looks like that, right? It's this curve, right? But then from 3 onward, it's decreasing concave up. Okay, so we get that sort of a graph. Okay, so I hope we can see that there is a little bit of subtlety when sketching the actual graph. Don't worry just about your points that you get from the derivative. Worry also about your intercepts and especially your horizontal asymptotes. And, of course, your vertical asymptotes, right? All right, so that's how you do that one. So one little exercise, little, would be to try this guy right here. Derivatives can get a little nasty, especially the second derivative. But it's worth trying. Might take you a little bit of time. See if you can do it.